Hello and welcome to part 7 of Dev Maths and Stats Refresher Course, Lecture 7. And we're here on to the last question about these multivariate distributions and the workers. So I've already pasted this into the whiteboard. So what we're doing is E1 is going to indicate 1 if they had any week work at all in week 1, otherwise 0. So in other words, what that's doing is E1 is collapsing all these 7 different possibilities into 2 different possibilities. So one of them is going to have that. So that's the probability of getting no week at all. That's the probability that E1 is equal to 0. But the probability that E1 is equal to 1 is that they got some work during the first week, which is either 1 or 2 or 3 or 4 or 5 or 6 or 7 days. So you have to add all those probabilities up. So that's the chance that E1 is 1, that's the chance that E1 is 0, that's the chance it's 1. Okay, so let's just start drawing that out. So this represents the first week, so the chance they got some work, and the chance they got no work. It was 0.305, 0.685. Okay, so week 2. So here's E1 equals E2 equals 1. So they got some work in the second week, no work in the second week, some work in the second week, press the equal signs, and no work in the second week. We have to get these probabilities. So if they worked in the first week, what's the chance they if they worked in the first week, what's the chance they also worked in the second week? So it's a conditional probability, and that's so what we want here is probability that they work in E2 equals 1, given that E1 equals 1. And remember, this is the probability that they're both equal to 1. Divide the probability that E1 equals 1. According to Bayes' law, because you divide by the probability that the given one here. So probability they're both 1 divided by probability that E1 is 1. So probability they're both 1 is the probability they got some work in both of the weeks. So it's all these possibilities here. Yeah. So that's the probability that both E1 and E2 are 1, because they got some work in both weeks. Going for small e's, never mind. So that's all of this. So that's that, and then to find the conditional probability we want, we have to divide by probability, that's E1 which is just this one. So and that gives us the probability that E2 equals 1, given that so that gives the conditional probability 1. I'm making up this because we need to calculate quite a few of these to fill in the table. And this is equal to that one divided by that one. Just a second. Take this back to up here. Put this on here. It's 770803. It's just 08. And then we want a few more. We need E2, E1, we need E0, E1, and E0, E2. So I'll stop doing the E's. So you want E1 and all different possibilities. 2 equals 0, and you want 1 equals 0 and 2 equals 1, and you want 1 equals 0 and E2 equals 0. So E1 is 1, E2, so that means the chance that it got, we work in all the chances they got work in the first week, not in the second week. So that's work in the first week is all these, but 0 in the second week, so it's all these here. Oops. So E2 is 0, but they did get work in the first week is all those possibilities. The chance that they didn't get work in the first week, but they did get work in the second week, is the kind of the opposite ones up here. So nothing in the first week, did get something in the second week. And the last one is they got nothing in the first week or nothing in the second week, and that's just that one sad case here that we had already. Nothing in both weeks. The end result we're trying to get is here. We want, again, leaving out the brackets, I want to find what's the chance that E2 comes out as 0, given that E1 was 1, E1 was equal to 1, what's the chance that E2 comes out as 1, given that E1 was 0, and what's the chance E2 comes out as 0 if E1 was 0. So these are the other probabilities that can go on these branches here. What's the chance of E2 if the first was E1? What's the chance of E2 0 if the first was 1? E2 1 if the first was 0, E2 0 if the first was 0. So those are all the ones we're working out. To get this, we need to divide the 1 0, that probability, by the 1 probability. So it's both these here. I need also need P E1 equals 0. It's just this here. Okay, so probability E2 divided by E6. This one divided by E1 is 1. So it's the probability of E2 is 0, given that E1 is 1, is, again, you're dividing by this one, so that E1 is 1 probability, and you look at the joint of E1, E2 being 0, E2 being 0, well, E1 was 1. And here you want probability that 2 is 1 while E1 was 0. So that's 2 is 1 while E1 was 0. That's the chance of, so the joint one, E2 is 1 while E1 was 0. So it's this one divided by the probability that E1 was 0, which is that. And the final one, both 0. What's the chance of the both 0? What's the chance the second one is 0 given the first one was 0? It's the chance of both of them being 0 divided by the chance the first one was 0. And okay. And in both cases these should add up to 0. So this and this is these should add up to 1 in each case. Yep. So 0.7708, 0.2292, 0.700, 0.2292 adds to 0, and this is 0.4 and 0.6. What a lot of words get that. Each branch and outcome with appropriate probabilities. Okay, well, this one would be 0.685 times 0.7708, and so on. This times this is still that. But I'm not going to write that down, so I get 0 because it's just taking too much room. So we've done that. Right, A. Once you've got the diagram, use the diagram to find the probability the workers employed in week 2 if they were employed in week 1. So what you're asking here is what was the probability that were employed in week 2. So this has got to be 1 to indicate they were employed in week 2, given that they were employed in week 1. So both E2 are like, we call them like a Boolean flag. So it's 1 if they were employed, not if they're not employed. So what's the chance that the second one is 1 if the first one was 1? And that we've actually got here. So that's not going to take a huge amount of time. That's question 1. Question 2, however, is the flip side. What's the probability that they were employed in week 1? So that flag is equal signs. So it's just the old chestnut about trying to reverse these. What's the chance? I can draw this properly. I hope you're not finding it as annoying as me that I can't draw these things. What's the chance that E1 was 1, given that E2 was 1? So what's the chance they had some kind of job in the first week if you know they had some kind of job in the second week? And that's where we can't, it'll be different from this. So we have to use the Bayesian rule where you look at the joint probability, the probability they got both of these things happening. One divided by the probability of just this second part happening. Probability of E1. Probability, sorry, of E2 being 1. So the probability that they got job in some way, I think I've answered that already. We had the chance that they got some kind of job in both weeks. What's that one? Oh yes, this one, isn't it? So that's the probability they got some kind of job in both the weeks. It's 0.528. Divided by the probability that in the second week they got some sort of job. If you haven't yet worked it out. And that's, instead of these margins, it's these marginal probabilities. So it's all the marginal probabilities except for 0. So that's the probability they got some sort of job in the second week. Interesting. So put an equal sign. There we go. 1.654. Which is going to give you now this other conditional inference, which is probability. So see again, it's the joint probability divided by this marginal probability. Now, so you can see it's bigger than this one. It's not the same as that, so 0.80734. That's the right thing. And it took me so long to get back there, I forgot it, 0.80734. 80734. So it's yet another demonstration. You can't flip these things around. This is saying, what's the chance they got some days work in the second week if they got some days work in the first week is that. But the chance they got some days work in the first week if they got some days work in the second week is different, is higher in this case. So you can't just flip from one to the other. So bear that in mind in the problem sheets and bear it in mind in the statistics tests we do and for all your econometrics work and basically your life, because it's a key point. Okay, so that's the end of the videos for this lecture. So I look forward to seeing how you get on with the probability questions, because they're always quite puzzling. For now, thanks for watching.